It's always fun to welcome back on Friday Jesse and Harrison, the Beyond the Sun guys. So we're going to talk about shiny objects on Mars.
That's it. And
Turns
out, hold on your hat.
Mars is trying to distract us with shiny objects.
Not caused by aliens.
Oh, darn.
A picture came out on April 3rd that Curiosity, that's roving around on Mars, took of the landscape. It was looking at the mountain in the distance. And they noticed in part of the image that there was part of it that looked shiny. Okay. And so a paper in Houston, the Houston Chronicle, who's the first person you call when the Curiosity rover sends back a picture you don't understand? They called a UFO sightings group. Oh. And those people said, it's aliens.
Yeah, of course they did.
NASA then, of course, has come out and offered a couple more reasonable explanations. One is that it's possible that the camera, the sensor, the CCD sensor, like what you have in your BlackBerry here, or any digital camera, it has these CCD sensors in it. It's possible it got hit by a cosmic ray. And you can see on the screen now the arrow
that is a shiny object.
It's a weird shiny. It shouldn't be there in the picture. So option one, cosmic ray. It's a charged particle, could have hit the sensor in the camera. And
No, I'm keeping track. And option one was alien.
Option two is...
and speaking as an astronomer who deals with taking astronomical images, cosmic rays are a huge issue, and they really blow out your images. So quite obviously can be very, very bright things in your camera.
Yeah.
Okay.
And this is actually something that happens commonly in space images because there's no atmosphere to protect the camera, to absorb those cosmic rays. And so these charged particles can hit the sensors, and the sensors don't know the difference between a cosmic ray or the light coming in through the front of it that it's supposed to be taking the picture of.
Okay.
So that's option two. The third option is that it could have been like a shiny rock, and it's glinting and it caught the light just right. But
some sort of metal?
Some sort of metal, or
could be a metallic rock, or just a shiny rock of some.
It happens.
Yeah, some crystal or some whatever way this rock is formed could have been glinting sun in just that right angle, focusing it into the lens of the camera. Yeah. But that one's slightly less favored. It seems more like a cosmic ray.
Okay. Well, can they move closer to it?
They could. I doubt they will. I'm sure
on this image, they wouldn't move closer because the NASA scientists aren't particularly interested in a cosmic ray having hit the camera. That happens continuously. They send pictures back every week with this sort of thing. So for NASA, this one's not really much of a story. For the UFO folks, it is, but it's important, I think, to get the real information out there so you're not caught up in the
not exciting at NASA, but pretty exciting on the 2 a.m. talk shows on the radio.
Yes, exactly.
Internet talk radio.
Yes, and internet talk radios particularly.
Yes.
You guys said when you came in here, Mars is at opposition. What does that mean?
It is indeed. It's opposing the sun.
Well, the sun will win.
Yes, it always will. The sun will always win. Yeah, so Mars is at opposition. What that means is from our point of view on Earth, here's Earth, we have an Earth here. From our point of view on Earth, and you have the sun right there, and we're going to use this both as Mars and the moon, a moon later on. So here we have Mars, here we have Earth, and we have the sun, and they're in a line. And so from our point of view on Earth, Mars is exactly opposite the sky as the sun.
Okay.
And as a result, that means we're really close to it.
Oh, okay.
Which means it's a good time to go observing.
Is this as close as we get?
Great question, Jerry. I'm so glad that you asked that. You see, it is not exactly, opposition is not the exact closest approach. It's actually, this time, about 7 days later. So opposition, when we were in a line, happened on Monday, the 7th, and closest approach is on the 14th. And the reason that we have these two differences is because we both orbit the sun with elliptical orbits, not perfectly circular orbits. And that, as a result, makes those days not necessarily line up.
But they'll be close.
Yeah.
Now, when you say close, it's all a relative thing because of the distances. So how much difference does it actually make in terms of just the ordinary person wanting to look at Mars?
For the ordinary person, if you're outside and you see a bright light up in the sky, Mars can be almost twice as bright. I think it's something like twice as bright.
Yeah, much brighter.
Really?
On times like this versus when it's, back to what Jesse was saying here, when we're all in a line like this versus if Mars is over on the other side. It can be quite a difference in terms of how bright Mars appears in the sky.
And right now, it's as bright, Mars is as bright as the brightest star in the sky right now, which is Sirius. So it's quite blazing and quite beautiful. And since it comes up right when the sun goes down, it's quite a beautiful sight all the way through the night.
Would it be first star, that kind of thing? It's not a star, but...
almost, yeah.
It'd be among the first ones you could see. It'd be a little bit low in the horizon, right first thing, but it would be certainly near the beginning. It has this reddish tint. If you go outside at midnight, it will be straight up. A little before, it would be a little to the east. A little after, it would be a little to the west.
And if you're a
can't
person
miss
who
it.
has a telescope, would it make a difference? Like you can see that much more.
It's much, because we're closer to it, quite literally closer to it, it gets a wider field of view in your image, in your lens, looking through the telescope. And so you can see a lot better Mars. And this isn't going to happen again for another 2 years because we don't line up for
Yeah.
2 year
It's
intervals.
every 700 and some odd days.
So it's the best time to look for shiny objects.
That's it.
Absolutely.
Now, one thing you wanted to mention quickly, and we'll come back and talk about the Deep Space Network and the lunar eclipse. NASA's starting to think it might be a little tougher to go to Mars than we thought.
Yeah, there's an interesting research study that just came out last week where they're studying astronauts' eyes. Now, NASA's known for quite a while that eyes are affected when you're in space because your body's pressures change when you're in zero gravity. And it turns out that it impacts the shape of your eyeball, and that impacts the lens and how you can focus on objects. And they're finding that it's actually having more of an impact than they thought. It's going to be really interesting to see later this year when the first astronaut goes up to the International Space Station for a 1-year stay. That's going to be really important to see how the human body reacts to being in space.
So
for
that's
long
going
periods.
to happen?
Yep,
Oh, yes.
Yep, yeah, there are
And
two
how many people will do it?
There's going to be two, one American, one Russian, and it's going to happen over the next couple years. The first one
Yeah.
goes up this year.
Will we send visitors?
Well, yeah, the regular crews will come and go, so,
Okay.
so they're not going to be by
But
themselves.
the experiment is that these two will stay for an
see
entire
what
year.
ha- to see
What's
what
been the
happens.
longest so far?
6 months.
6 is the average. I think there's been,
Yeah, there's been a couple-
cosmonauts have gone longer.
A little bit longer,
yeah.
but not
Okay.
not the full year,
Yeah.
and not with all these, not with current medical research to really understand. Because a Mars
All
mission,
right.
remember, a
That's
Mars
key.
mission is 3 years.
To
So-
get there?
Well,
And
to
come
get
back.
to get there and,
And
come
come
back, 'cause
back.
it's a round trip. But
Okay.
we're not
And
just
that's
doing
what,
one.
involving touched it and now come back?
Yeah, well, and
Pretty
once
much.
you get there,
Yeah.
you have to wait a little bit of time because the planets, like we were talking about, don't line up all the
right.
time. So it's a long mission.
All right, coming up, we'll talk Deep Space Network and Lunar Eclipse with our Beyond the Sun guys on Straight Talk. Our Beyond the Sun guys are here, Jesse and Harrison. Lunar Eclipse upcoming.
Oh yes, this Monday through into Tuesday morning. So, well,
Okay.
actually, it starts Tuesday morning at 2 a.m. But you have to stay up
If it's not cloudy.
if it's not cloudy. That's the one thing. See,
Yeah.
there's two kinds of eclipses, right? There's a lunar eclipse and a solar eclipse. Solar eclipses, you need special protection and everything. Lunar eclipses, you do not, because it's
right.
all about the moon. So
Okay.
we're going to use our model here to show you again. Harrison, you want to hold up the sun? So we got the sun.
Yep.
Shining on the Earth, which then casts the shadow out into space.
Yes.
As of course, that's what we call nighttime, right?
Yeah.
And then the moon just slides right into the shadow of the Earth.
It doesn't usually.
In behind, yeah.
Doesn't usually. Great question. Wouldn't
Okay.
that happen every month because the orbit of the moon goes
Yeah.
around once every month? No, it's because the orbit of the moon is tilted.
I
So
see.
the lineup only happens once in a while.
So the shadow is shooting out there, and then the moon is up here outside the shadow.
Yeah.
Generally.
Generally.
Yeah.
Now this time it's going right into the shadow of the Earth, and it's going to turn this really dark, deep red, reddish, purpley color.
Yep.
Really?
It's
Yep.
beautiful.
Well, it's as all the sunlight goes through the Earth's atmosphere, it sort of refracts, and so some light still does reach the moon, but it's not it's not direct, it's not crisp, so you get that sort
Okay.
of reddish glow. It's also interesting as well that first graphic that was up a second ago that showed the picture of the Earth. It's that lunar when they happen, they're not necessarily visible. This image here, you can see the top half of that is showing where the shadow is going to be, where the Earth passes, and then the bottom shows you where on the world it's going to be visible from. Because when these things happen, you don't always necessarily see all of the moon. Not everybody has a view of the moon.
So we're not going to see this?
Well, we will.
Maybe I'm not reading the map correctly.
Yeah, no, we will.
All right.
Yeah, we'll see it.
We'll
Okay.
see it. But it's interesting that not everybody else sees things. This is more true in solar eclipses where, depending on where you are, the shadow can be small. Lunar eclipses are a little easier to see.
Okay, so it will change the color. What phase of the moon are we seeing?
You have to. This can only happen in
When it-
full moon.
yeah.
Because
Okay.
the moon has to be on the
A lot of
opposite
things
side.
have to come together.
That's it.
It does.
Yeah,
It's a,
it
Yeah.
has to be perfectly aligned. And if it's not perfectly aligned, like if it's a quarter moon, then you don't get the Earth blocking the shadow of the
Okay.
sunlight.
Would it create an image for a bit on the moon that looks like a quarter moon, like the shape of the Earth is kind of cast onto the?
Actually, yes. As it slides into the shadow, parts of it get more and more shadowed, and then
Yes.
eventually it turns this nice, fully red color. And then as it slides out the other side, it looks like a quarter moon again.
Mm-hmm.
So you see sort of almost all the phases of the moon.
In
Not
a-
actuality.
in a short
over
period
an
of
hour.
time.
short period of
Yeah.
time. Yeah.
And would you go, wow?
You would. I highly recommend it. The downside is that even if there was no clouds and it was a beautiful observing night, you have to get up at 4 a.m. to see the totality of this. And I don't know about you, but I'm not usually up at 4 a.m.
I got to do that once.
have to get up at 5
I
anyways,
was
right?
on,
Oh,
so
see,
just
you're
get up a
good.
little early.
Get
and
up a
you can
little
see it.
early.
I got to look at one once when I was on vacation down in the Caribbean, and it's less of an issue to stay up all night then.
You're
Yeah,
up
yeah,
at-
so
You're
you're
still up.
It is
But
quick.
worth it?
Oh yeah, no, we
They're beautiful.
sat out on the beach.
All right.
I had my camera, and it was very neat.
All right. Now, Deep Space Network you wanted to talk about.
Long-distance phone calls.
Long-distance phone calls. The Deep Space Network is NASA's network of radio dishes that talk to all the human-made things that we've sent out into the solar system.
Okay.
Into
Yeah.
deep space. So we're not talking
All of the
low Earth orbit.
satellites and...
Well, don't think the things that are nearby. Think about things
Oh.
like Voyager 1 out on the edge of the solar system, Curiosity that's on Mars, missions to the moon, things like that. Not the stuff that's right
orbiting.
nearby. The stuff that's
non-orbital stuff.
And
Well,
here's a
yes.
couple of the dishes you're seeing. They're just radio telescopes sitting on the
Okay.
surface of Earth that chat with these things really, really far away that we've made. And it happened to be the 50-year anniversary of building this Deep Space Network.
which was built for, any guesses? Where was the first place it went to that was far away about 50 years ago?
You mean, what was it talking to? Well, the moon?
Think
No?
lunar, yeah, moon.
Okay.
It's to go with the Apollo missions. This is a
That
piece of
wasn't that good
technology.
a guess. What, has anybody talked back?
Well, the spacecraft do all the
spacecraft.
time.
No, but I mean...
Other people, no.
Aren't there people who are actually hoping for that sort of thing, waiting, like, can it receive that sort of signal if somebody...
Well, these ones aren't. You're talking something more like SETI.
Yeah.
And it's the same idea. It's a massive network of radio dishes, but those ones are sort of listening blind. They're pointing to dark spots in the sky and seeing what the radio signals coming back are. These ones are targeted very specifically at things that we know will respond.
Are these things in various places around the world, or is there a place?
No, there's 3 places. There's one in California, Australia, and I think Spain is the other one because
Yeah.
you have to have
There's a few
coverage
places.
of 360 degrees of the sky, so you can communicate all the
Yeah,
time.
strategically set up so that when one sort of sets, the other one comes up on the other side of the horizon so it can keep talking to wherever you're trying to talk to.
Is there like a home version? No, yeah, well, you know, like you can listen to police radio, you can listen to regular radio.
This stuff would all
no.
be, it's all digital, so it would just be ones and zeros.
Oh, well, yeah, but it can be interpreted into something.
That's true.
Certainly, yeah, I've never heard of anybody being able to intercept any of this stuff.
Yeah,
I don't
and
know.
the
That's a
signals
good
coming
question.
back from the spacecraft, unless you had access to one of these dishes, would be incredibly weak. That's why these dishes are so massive. They're
Oh,
30
I see.
meter dishes.
Like just sticking a dish up on your roof is not
Yeah.
going to get it done.
You're not getting
No, that
anything.
won't work, yeah.
Okay. Always great to have you guys. Thanks so much.
Thank
Sure.
you.